So now we are inside the ATO scan box, and what you do here now?
As you can see, this is the part Miro showed us before. This is the single tray handle from one of our laundry care machines, and this is now placed inside the scan box here, and especially it's placed inside a reference point frame, which is also designed by our development team, and we are closely working together for those parts. And we also have some parts which are coming directly from a 3D printer, like those adapters. Yeah. So we can easily get some 3D printed part for new parts, which might come today or tomorrow.
So I thought you use a lot of fixtures for this, for different parts, for different part sizes, for different applications on your laundry care?
Yeah. We tried to find a system where we can easily change for different part sizes. So we have mainly a base retainer, which you can see here. So this is basically just screwed onto the rotation table, and we can easily change only the frame on top of the retainer. So we have different part sizes, so different measurement volumes for different part sizes, so we need different sizes also in the reference point frame. Yeah.
Okay.
So here you have 3 different sizes which are capable of having many parts placed in.
So this is the basis for measuring with the ATO scan box. Use a situation with reference points, and now you go to your part and do exactly what?
Well, so here in Berlin we are responsible to program the whole inspection process. So we have other sites in China and Poland and Turkey, for example, which are using the exact same ATO scan box, and we are trying to provide the template for the inspection for all other sites. So
all measuring templates you produce here, do the inspection plan, and give them to the facilities out there which produces the single parts, and so you ensure that every site, every production site use the same evaluation template.
Exactly. So we are not only providing those templates for our other BSH companies, so also for other suppliers which have to do the qualification for single parts or sub-assemblies. Yes.
So this is only a small part of a washing machine. So
yes.
You only use this ATO scan box for the small parts?
We are using the ATO scan box for so many different parts. They are different in size and shape and color, even in material. And from the smallest part to a whole machine assembly we can put on this rotation table.
Okay, so I would say maybe we start a measuring setup, see what we can get out of this for data.
Yeah, let's look how it works.
I take the frames and...
Yeah.
So now we want to start the measurements. So maybe you can show me a little bit the project you already prepared and see how it works.
Yeah, so what you can see here now is the virtual measuring room. So this is one of the different workspaces inside the GOM software, and here you can see all the stuff that is put in our scan box in reality. You have all our frames, you have the retainer and also the CAD part itself. And here we program all measurement positions which are needed to get the full surface of our actual part. And we also have all the inspection elements which are needed too, and in the result of that we also have the access to all the report pages coming out of this template.
So these are the evaluation elements we get from the CAD department.
Exactly,
okay.
Yeah. So when this is done, this can be sent to all other sites in our factories, and it's quite easy to start the scanning process.
So I see now we are using the software exactly on the touch screen, but of course it's possible to use maybe the kiosk mode for this application, but why you don't use it at the moment?
We started not to use it first because we have a lot of different parts every day, so we have to do sometimes several different programs each day. So therefore we decided not to use the kiosk first. So for example, for a lot of first article inspection, it's not needed now in the daily business for us, but when this one is sent to another site which has measuring parts 20 times a day, then the kiosk would be nice for the operator to have easy access for the templates.
In the different facilities they use a kiosk modus. Here you decide because different parts each day, different first articles, that they use only the software, and of course it still works, so I think we can start. So I push the button for you.
Yeah, and we just start the scanning process by choosing the scan that we programmed first.
So nice to see that we see the remaining time here for the first run through the part, and
Yeah, so now we have, I think, about 50 measurement positions. The part on the back side is quite complex, so we have a lot of hooks, a lot of small details we need to measure, and that's the reason why you have to do a couple of measurements here, which takes 7 minutes, I think.
So injection molded parts are often difficult to measure because you have a smooth surface which defines the character or the shape of your final product, and a lot of special elements like hooks, etc., on the back side, and this is what is necessary here to define exactly for your different plans. They use your evaluation template later.
Yes. Yeah. And even when you think about bigger parts, like a big control panel for the whole machine, which is almost 600 millimeter wide, then you have quite a big part, but on the back side you have details which might be just a couple of millimeters in size. So, yeah.
So the scan is finished now. Let's see the results.
Yeah, let's have a look in the report pages here. So basically the first report puts all together all keywords we need, part name, tool number, cavity, so you can individually put all critics in there you want. And so for example, you get a content page. Normally we do a page where you can see the actual tool and cavity number of the part you just scanned, and it's followed by like a table with all elements, and after that we have normally the inspection of our datum elements so that we can be sure that everything is fine. So you have 3 different slides for that, and this is normally followed by our 3D deviation analysis, which is which gives you the most information about the part because we scanned it completely.
About the shape, not only the single values, to see the whole shape of the part.
That's actually the main benefit that we have with this data.
Okay. A digital twin out of the scan, and this is only a single part of a washing machine. So you told me that you of course inspect full machines. Where we can see this?
Let's have a look in the laboratory right next to us, and I will show you.
Okay.
Let's go.
So now we're here inside your laboratory. So I see you use flexible mobile equipment. for what exactly you use this flexible solution?
Yeah, this is one of our smallest equipment, the ATOS Q, and this allows the most flexibility. So you can work from machine to machine. You can change the room. You can go to other sites. So it's it's something which fits into a single suitcase, for example. So it's really easy to get to another site if the problems occur. And in this case, we are going to inspect an assembled situation of our tray handle we saw before and the control panel body. So in this case, you have gaps between the tray handle and the control panel, and this is obviously something which can be critical to customer because it's easily recognized if something is not in size. So if the gap is not big enough or if it's too small, it can easily be recognized by the customer. So this is something we need to check every time, and in this case it's quite easy to make a couple of measurements in the assembled situation, and when this is done we can just disassemble those two parts and do some single measurements for each part, and we all put it together in the GOM software and can easily recognize the gaps.
Yeah, okay, so we want to measure these gaps now, starting with the panel. So I can think we start with the first measurement.
Yeah, of course. We can just make a single measurement here, and it takes a few seconds, and you can see how many data was generated. And this would, of course, needs to be done with the tray handle as well. And after assembling everything virtually, we can analyze the gap quite quick.
Okay, so this was the first step. The measurement is done, so we go to the analyzation.
Yeah, of course. So here we have also the polygonized mesh data of the tray handle and the control panel. So what you can see here now is the region of our interest now, which is on the left side of the control panel, and we also have all the data of our tray handle. So if you want to see the assembled situation, you have both single measurements in one file, I would say, and it's now quite easy to analyze the faces between our tray handle and our control panel, which is causing.
So this is a great opportunity, I think, to measure every part itself, do the evaluation against CAD files, etc., and of course analyze the assembly situation to get the gap analysis between both elements to get a smooth surface. That is what you talk about, that your customer expect high quality surfaces to get a quite good look and feel for your washing machines.
And one big advantage is this can be done easily, so it can easily be learned and trained, and there's almost no operator which can't do this analyzation. And
so I think this is the point where I want to leave now, because I see you have a lot of work right in front of you. So thanks for having us here today to have a great look inside your work, inside the work of BSH, inside the different tasks you are facing with the solutions you're working on. Thank you very much.
Yeah, you're welcome. Have a nice trip home, Florian.
Yeah, thank you.